Hi guys, welcome to Module 2. This week we're going to talk about client-side technologies and some security issues surrounding those client-side technologies. I hope you enjoyed Module 1. I know it was a lot of number theory, but it's pretty important to understand how RSA works, especially when we're doing things on the web, in my mind. So I hope you enjoyed it. If it was a struggle or if it was not of interest, the one thing I can say is that we're not going to be doing much theory, well, probably any theory at all, for the rest of the course. So we're definitely done with that portion. But this week we're going to move on and talk about client-side technologies. And as we touched on in Module 1, when we talk about the client side, we're basically talking about the end user. So picture a user connected to the web, either through maybe a cellular phone connecting to Instagram or their laptop or tablet at home connecting to Netflix, something like that. The client is basically the consumer of the data. And one of the most popular protocols that we know of to exchange data over the public internet is HTTP. And HTTP stands for Hypertext Transfer Protocol. And there are a number of HTTP verbs that we use to either get data from a web server, or maybe to alter data there, or delete it, or to post new data to the web. So one of the most common things, and maybe one of the most prevalent verbs that we see, is something called an HTTP GET method, or HTTP GET request. An HTTP GET you can basically think of as being a read operation of a document that's on a server. So for example, if you go to www.google.com, you're going to issue an HTTP GET, which is going to request from google.com a page called index.html. And your browser is going to go out to that web server, request the data, and when it gets back to your client side machine, be it a tablet or a laptop or any number of computing devices, it's going to render that data into the browser for you. So along with that, in addition to HTTP, there are a number of client-side technologies that are downloaded as part of the HTTP GET. And that code is downloaded directly to your browser and it's executed locally. So rather than being executed on the remote server, your browser downloads something, so maybe a JavaScript file, interprets it, and then runs it locally in your browser. And whether you realize it or not, you've probably seen many, many examples of this, and we're going to talk about and look at some of those examples later. But one of the nice things about client-side technologies is that they actually manipulate the web page as you see it in your browser, and it can do it in response to different user actions that you generate. So for example, we'll see a small picture of this in one of the slides to come, but you can think of if you've ever signed up for a new account on a website, and as you press each key, right, the web page updates telling you that your password is not yet secure enough, right? It starts out as red, and as you press a capital letter and a number or a punctuation key, right, it moves to yellow and then gradually to green, to being acceptable. So you see in the picture below, we see the HTTP request to the server, we see an HTTP response. The nice thing about the client-side technologies is once you download something like that JavaScript file, it just executes locally, so there's no need to send data back to the web server. Everything is getting manipulated right there, whether using Chrome or Internet Explorer or Firefox or Opera or one of the many browsers that exist. Everything's being done right there on your computer rather than having to reach out to the server to generate updated behavior in your browser in response to the things that you do. So we're going to talk about some of the implications of those client-side technologies, why they're important, and then also some of the benefits and drawbacks. Here's a list of some of the benefits and drawbacks that we can expect to encounter when we're dealing with client-side technologies. The biggest one that comes to mind is definitely performance. We talked about this a little bit in the previous slide, but when you download a client-side technology, so JavaScript is a prime example of this, when your browser goes out and pulls down a web page, it may also pull down one or a number of JavaScript files additionally. So that way, when you're interacting with a page, certain user actions trigger an event in the JavaScript code. So one thing that can trigger an event is a key press. Another thing that can trigger an event is the release of a key. or the left click of the mouse, or the right click. Or if you mouse over a certain region of a web page, you get a certain pop-up. But when you move your mouse away, the pop-up goes away. So those things are all done, actually, believe it or not, within the context of your browser. So what would really be bad is if, as you're interacting with a web page, your application had to take the time to take your request and say, okay, the mouse moved over this region of the page, so let me go reach out across the internet and contact the server and tell the server that you moused over this. And the server says, okay, well, given that Joe moused over this region, I want to display this pop-up. So I'm going to send this pop-up back to him to receive on his browser. That'd be really, really slow and inefficient to have to reach out to the server each and every time a user interacted with the page. So when you download these types of scripts, like the JavaScript that we mentioned, the nice thing is that it happens all locally in your browser. So your browser downloads those scripts and has access to that functionality. And then when you, say, click a certain region or press a certain key, the JavaScript actually triggers an event and launches a function in response to that user event. And the net effect of this is the second point here, which is usability. So these client-side languages provide a really great user experience. When we mentioned the password meter in the previous slide, and you can think of times when, as you're typing a password, it tells you your password's getting stronger or your password's not strong enough. But by and large, what's happening is your page is basically modified in response to the actions that you take within the context of your web browser. So here's an example of something that is not a client-side program. You've used probably Google search before, I'm sure all of you have. And as you type in each key, you see that a feature called Google Suggest will begin to predict what it is you're typing. So if I type E, A, G, it may begin to think I'm typing Eagles, for example, for the team who just won the most recent Super Bowl. And based on popularity and based on each key you press, it returns a list of potential search results that you're likely to type in based on what you've already typed. That's actually not a client-side technology. What's happening is Google is taking each key that you press, they're sending it off to their server and then processing it and saying, okay, you've typed E, now A, now G, now L. And so the results begin to get more and more specific. Okay, but that's actually not client-side. So when you think client-side, think of things that change within the browser in response to you typing. So the password box is one perfect example of that. We can think of many, many different types of form validation. So for example, if you're registering for a new website and you leave the email field blank, it may give you a notification when you click submit or click the register button, like, hey, wait a second, you didn't, complete this field correctly. So then you go back to fill in the email field and notice at each key press you type, it tells you when you've entered a valid email or not, which, as you know, is a few letters followed by an @ sign, followed by a domain name, followed by a period, followed by some web suffix, so .com or .net. And each key that you type, it's able to actually process it locally until you've entered a valid email address, in which case it might turn the field green or something like that. Okay? So that's a little bit about the difference between client-side programming and Google Suggest, which sends things off to the server for processing. So a big difference between the two. And though there are benefits, there are drawbacks as well. So while performance is definitely one of the main benefits, potentially it can be a drawback. So it depends on what it is that you're trying to accomplish. If you're reaching out to try to pull some data back from a server, you don't want that server to have to download all of its information locally to the client machine and then try to do a query on a large data set. What you'd rather do is send a teeny tiny query off to a big beefy server, run that query there, and then just return the results that are pertinent to your query. So again, it depends on what you're doing. If you're doing small things like form validation in the user browser, that's probably best suited locally, but something like a large database query, that's something for sure you're going to want to send off to the server. Another difficulty when dealing with things like JavaScript is that browsers may, and in fact definitely do, interpret some of these languages differently. Though there are specifications for the languages, the the Chrome implementation of JavaScript or the Firefox implementation, I'm sure you've maybe tried to write web pages before where things are interpreted slightly differently. And so you get slightly different results. And that can be problematic, especially if you're a front-end designer, where one method works in one browser, but maybe the same JavaScript method is not supported across all browsers. So you get different incompatibilities depending on which browser you're using. So that's definitely a difficulty if you're working on the front end. And then finally, security is definitely a concern when talking about client-side programming. We're going to see some more specific examples of some client-side vulnerabilities later in this module. But one of the big things is when you're interacting with a server, you send off your database query, for example, you're not sure really what they do with it or how they might optimize your query or what. You just know that the data that you get back is correct. So you can't actually see the code and you can't see how the things are implemented. But when you're dealing with a client-side technology, since those scripts are downloaded locally into your browser, it's completely possible that you can just pull those up and see exactly how the implementation is done, which means an attacker can actually do the same exact thing. They can see the implementation of the code that people are downloading as well. And so they're able to see if it's susceptible to certain types of vulnerabilities, which may enable them to launch an attack against you. So we're going to talk again in more detail specifically about that later. But again, just wanted to cover some of the benefits and drawbacks with some of these client-side programming technologies. One of the most popular client-side scripting languages that exist today, that I'm sure you've probably all heard of, is something called JavaScript. So as you see here, JavaScript is definitely a client-side language. It's not a server-side language. And despite the name, it has some similarities, but it's not really based on Java, which a lot of people mistake or they think it's derived from Java somehow. Syntactically, it has some similarities, but paradigmatically, it's a bit different. So what I mean by that is, one of the similarities is that JavaScript is actually an object-oriented language, even though it's for front-end development primarily. So when you see some JavaScript code, you might be familiar with the notation. You might see, x dot index of. So x is an instance of some object. Maybe it's a web page or a control within a web page or something like that. And it has a whole series of methods, just like in Java. So some of the syntax might be familiar. But one of the major differences is that JavaScript is interpreted, it's not compiled. So the interpretation of code tends to happen closer to runtime, so it's a little bit faster. You don't have to compile through all the code and resolve all dependencies up front. Interpreting happens a little bit more on the fly, but the reason that's nice for a client-side language is because it gives you a little bit better performance guarantees than a compiled language. And so as we said, it's object-oriented, but it's not actually based on classes, which, as you know, Java is strictly based on classes and class inheritance and polymorphism and some of those things that are more on the software engineering side of the house. JavaScript tends to be based on functions. So we mentioned before that what JavaScript tries to do is take a control on a web page and basically map it to some JavaScript function so that when I click a button, a certain functionality is launched in response to that. So we'll see some examples of this as we get along with the slides. But just keep in mind that JavaScript is not based on classes like Java, but it tends to be more function-based. So when you look at a piece of code that's written in JavaScript, you'll notice that it's broken out by functions and not by classes. And the other thing that's interesting about JavaScript is it's contained within the web page itself. And we'll see that this can be actually embedded in the HTML, or it can just be a reference to an outside JavaScript from within an HTML page. But either way, the nice thing about JavaScript, again, we've mentioned this, but that it modifies the page code directly. So as you're interacting with the page, the JavaScript is able to invoke certain functions based on how you interact. So the user experience is definitely enhanced, and we're going to see some examples of how it's implemented in the future slides. Previously, we mentioned that JavaScript can be embedded directly into HTML code, or it's possible to link it externally. So to bring some clarity to that idea, I wanted to give you guys an example actually specifically in source code. So the top image you see here is a valid HTML file. So you see the beginning and the end HTML tags. and you see the beginning and end body tags. So within the body of the HTML document, which is usually what's rendered to the user, we see this tag, which is called a script. And you can see that the type on the script tag is a JavaScript script. So what that means is within those delimiters, within the start and end script tag, we can write valid Java code and it will be executed by the browser. What's going to happen is your browser is going to go out and fetch this web page, and it's going to download the HTML complete with the JavaScript embedded inside of it. And when it renders the HTML page in your browser, it's going to see that script tag, and it's going to go ahead and use its JavaScript interpreter to execute what's in between those script tags. So in this case in particular, it calls something called document.write. A document, you can basically think of that as the container for all the objects in the web page. We'll talk more about this in future slides. But it's going to take the document and it's going to write the string hello world followed by 3 exclamation points to your browser. So this is an example of where the JavaScript is embedded directly into the web page. But then contrast that with the example at the very bottom there. You see that there is a script tag, but notice that there is actually no Java code in between the beginning and end script tags. Instead, it has the type field just the same as before, but now it has a source field as well. And that source field is representing a file name, or it could be a path to a file. That file could be on your local file system, or the file could be somewhere on the web, for example. But what this is doing is saying, hey, once I am rendered in the browser and the interpreter goes to look for this JavaScript code, there's no JavaScript code here written, but I'm referencing this source file called file name. So what your browser is going to do is going to go navigate to the path that's specified by file name. It's going to download that JavaScript file. It's going to interpret it, and then it's going to be able to run that in your browser. So the code doesn't necessarily have to be embedded directly into the web page in order to be able to tie in JavaScript functionality. So these two things are used a little bit differently. If you have just a small amount of code to write, embedding it directly into the HTML is fine. But usually if you're going to have many, many functions, it probably makes sense to host it externally. Or if you're going to link in maybe some sort of external library like the Twitter Bootstrap library or something like that, or a jQuery library to add some JavaScript functionality to your website, instead of copying the stuff locally, it just makes more sense to use one of these external tags and just point it to a repo that's online that has all those functions written for you and just refer to them remotely. So when we talk about the difference between having JavaScript code embedded or linked externally, this is exactly what we're talking about right here. As we've been saying, JavaScript is an event-driven language. And what I mean by that is that the JavaScript functions are often mapped to a specific event so that when a user triggers one of those events, the JavaScript function is called in response to that user action. But I want to talk a little bit more about how that mapping occurs and how JavaScript is actually able to dynamically modify the elements in an HTML page. The key thing to know about here is something called an HTML DOM. And a DOM stands for a Document Object Model. And what it is, it's a model and interface that allows you to dynamically interact with the elements on a web page in such a way that it allows you to update those objects. So I've included a link here for reference. It's a lot of words to say model and interface and dynamic updating. So please take a look at this link, and I think it puts it in pretty easy to understand words. But it's the mechanism by which JavaScript is able to access the different objects on an HTML page and then modify them accordingly. So as I said, the DOM not only represents an interface to interacting with all of the objects on a page, but it also defines events for all HTML objects. And when I say objects, by the way, the things I'm talking about are HTML tables and drop-down menus or checkboxes or buttons, a submit button or a radio button, and text fields, a multiple select field, all things like that. Anything you've ever seen on an HTML page, that's what I mean by an HTML object, quite simply. So for example, I've listed some of the events here. There are many more objects that are supported, and there are many more functions that trigger events. But you can think of times when you've clicked on something and it's launched a pop-up. There's actually an event called onClick for a mouse, or on mouse over, which means when you move your arrow or your cursor over top of a certain element, something may pop up. Or on mouse move, when you move your mouse away, something may disappear. Same thing on a keyboard. You can think of times, and I've raised this password strength meter again here in the lower right. Right, on key down, on key up, on key press, they mean exactly what you think they might. So on key press, every time you press a letter, JavaScript's going to take that letter, or it's going to take the string that you've typed, letter by letter, and it's going to go through each element in your current password. It's going to see, does it contain upper, does it contain lower, does it contain punctuation, or does it contain two numbers, things like that. So these events, as I call them, are exactly the user events that we're going to respond to with the JavaScript function. And on the next slide, we're going to see a specific example of what that looks like. So here's an example of a very basic JavaScript function. You can see that in our page we have two main elements here. One of them is an input element, and its type is text. So what that really is just one of the input text box that you're very familiar with. So think of the text boxes that allow you to put in your email address when you register, or your username when you're trying to sign in for something like that. So there's an input text box there. And then we also have a very small embedded JavaScript on this page as well. And you can see that the JavaScript declares one function called myFunction. And you can see that that function just calls another JavaScript function called alert. And what alert does, that's how you get a pop-up on your screen with the specified text. So in this case, when the function myFunction is called, it's going to put a pop-up with an OK button at the bottom, and the text included in that pop-up is going to say, you pressed a key inside the input field. Okay, so notice that we'll refer back to the input field, and it has an event there specified called onKeyPress. And what that means is when a key is pressed, so not when a key is let go of, right? When a key is pressed, it's going to call myFunction. And we can see very clearly here that all myFunction is going to do is pop up that alert that we talked about. So you can see here that when someone clicks inside of the text box, and when they press a single key, it's going to pop up the alert box that says you press a key inside this field. And in fact, that doesn't happen once, that happens every time the onKeyPress event is triggered within that text box. So if I type J, I get a pop-up, I have to click OK. And then I type in O, I get that same pop-up, I click OK. I type in E, I get the same pop-up a third time for typing my name, J-O-E, and I click OK a third time. So every single time an onKeyPress event is encountered in that text box, it's going to refer to myFunction, and it's going to launch that code within your browser. So as you can see here, this is just a very straightforward, simple example of how an input element on an HTML page references a JavaScript function. As I'm sure you're aware, pop-up dialog boxes are actually very annoying. So I wanted to show you guys an example that I thought was a little bit more useful and maybe a more common use for how JavaScript is actually implemented on certain web pages. So you see here, instead of an input text box, this time we have a pure HTML button. The HTML button contains the text click me, and you can see that it has an onClick event. So when that button gets clicked, it's going to launch something called myFunction, which we'll see in a second. So that's pretty straightforward. The other thing here we see is a P tag. The P stands for paragraph. And what's a little bit different here, which we didn't have on the previous page, the paragraph tag contains an ID, an identification of the string demo. Okay, so this gives us a way to uniquely identify that specific paragraph tag. So in other words, if we had 2, 3, or maybe 100 different sets of paragraph tags, we can name them uniquely so that we can access them within that DOM that we talked about before. So remember that document object model. The ID gives you a very specific way to access a certain element within the DOM. And the third thing that you see here, again, is just another embedded JavaScript, and it declares a function called myFunction, but the code is a little bit different this time. So recall that a document in JavaScript is basically the container for the entire web page. So think of document as the page itself, and underneath of it, it has all the elements, the buttons and the drop downs and things like that. So we're going to call a very common method here called document. So give me the page, and then get element by ID. So then return to me the element whose ID is demo. And if we look just a couple lines up, like we saw before, that paragraph tag is precisely what has the ID demo. And then it's saying alter the inner HTML property of that element and set it to hello world. So hopefully you can kind of see the chain of events here. That button up top, when you click it, it's going to invoke the function myFunction. MyFunction is going to search the page for an element that has an ID called demo, which is that paragraph pair of tags right there. And then what it's going to do is it's going to alter its inner HTML, which basically means put whatever that follows the equal sign right between the two paragraph tags. So it's going to insert the text hello world in between those paragraph tags when you click the button. So initially when you load this page, it'll be blank except for a click me button. And then when you press click me, underneath of it, you're going to see the text hello world appear dynamically. And again, the interesting thing here is you don't have to reach out to the server to do it. The browser is able to understand this functionality. It knows where the function myFunction is. And so in response to the on-click event in the button at the top, it will render the text hello world inside of those paragraph tags. Now that you're hopefully beginning to get a feel for how JavaScript modifies elements in an HTML DOM to provide dynamic updates to a page, we can begin to think about some of the security implications of this. And one of the main things that come to mind when talking about JavaScript, the main vulnerability we think about is something called cross-site scripting, also referred to as XSS. So cross-site scripting involves taking input from a user that dynamically alters a page, but we exploit it in a certain way so that unsuspecting victims who then go on to load that page are susceptible to the attack. And we're going to, again, so we'll see examples of this in the next couple slides. But the problem occurs when certain applications or certain web servers don't validate the inputs that they're given. Okay, so an attacker who knows how to craft some malicious JavaScript, for example, if they find a web server or some web app that is running something that's versions and versions and versions of behind, and it doesn't check the inputs before taking action on them, then they know that that web server or that application is vulnerable to this class of exploit. And it's actually more powerful than it might seem, because if an attacker is able to successfully exploit a cross-site scripting vulnerability, then they're actually able to control your browser or whatever application it is that you're using inside of the browser. So that's kind of a scary thing, that they can steal your online identity that way, or they can steal the cookies from your browser and hijack your session or things of that nature. And there's two main types of cross-site scripting attacks, which we're going to talk about next. The first one is called stored, which involves the malicious JavaScript being stored on a server. And the other one's called reflected, which basically involves taking the malicious JavaScript and kind of bouncing it off of a web server at you in a certain sense, but enticing you to visit the exploitable web server kind of without your knowledge or against your will. So we're going to talk about the two types, both stored and reflected cross-site scripting attacks next. Now I'll talk a little bit about stored cross-site scripting specifically. In the context of a stored cross-site scripting attack, what happens is an attacker crafts malicious JavaScript code, finds an application that's vulnerable to it, and then actually posts, or we say injects, that malicious JavaScript code to that vulnerable server. And you can think of some of the most popular targets are things like blogs or a forum or social networks like Facebook, like your wall on Facebook, or message boards. And what happens is when the attacker posts the malicious code to that site. So when you go to visit it, for example, if you're interested in forums on, I don't know, spaceflight, for example, I'm just contriving an example here, but you visit your favorite spaceflight forum where people like to post questions and answers and responses and things of that nature. Well, what happens, when your browser goes and pulls that page, it downloads all of the content on that page into your local browser, right, from the web server. Well, what happens if one of the things that it downloads is a malicious piece of code, right? So the victim visits the site. It's just their favorite website. They have no idea that there's malicious code there. They download it unknowingly because they're just downloading one of their favorite, message board websites. And what happens is, since it's a client-side code, it gets run in the browser. So there's a pretty descriptive image here below. You can see the perpetrator, the attacker, finds a vulnerable website. And he injects some malicious code that, let's say, maybe doesn't do anything super fancy, but maybe it just steals your cookie. So the third thing that happens is you unknowingly, you don't know that that website has some malicious JavaScript code stored on it. You go to the website and you pull it down and render it in your browser, and you accidentally download that malicious JavaScript. And then you see step 4 here. Oh, by the way, once your browser executes that JavaScript on the client side, what it does is it goes locally, pulls your cookie from your web browser for your, it could be your spaceflight message board. It could be your Wells Fargo bank account. It could be a number of things. And you can see here that the visitor's session cookie is sent over to the attacker. So again, you have no way of knowing ahead of time that the site has malicious code on it. You just very innocuously go to pull the web page up on your phone or your computer, and then bam, since there was malicious JavaScript code stored on that vulnerable website, because, for example, it didn't validate the input from the attacker, well, now you get hit, and without knowing it, you are shipping your credentials or your session cookie or worse off to the attacker. So when we say a stored cross-site scripting attack, that's what we mean, that the attacker actually injects real malicious code onto a website, and then when you visit it, completely unknowingly, you download and execute that code, and then without knowing it, you've had a cross-site scripting attack launched against you. Now we'll contrast a stored cross-site scripting attack with a reflected cross-site scripting attack. So the idea is a little bit the same in the sense that it's going to involve some malicious and carefully crafted JavaScript. But in this case, it's going to be reflected instead of stored on the website. So we'll talk about a little bit about what that means. So you see first and foremost here that instead of an attacker taking the malicious JavaScript and injecting it into a vulnerable web server, instead what they're going to do is reflect the malicious code off the web server. So many websites are capable of preventing the stored cross-site scripting attack because it's it's somewhat easy if you're at least just a little bit careful to be able to tell if someone's trying to embed malicious JavaScript in your web page. So what they do instead is the attacker will find a website that is susceptible to malicious scripting, but let's say that website is doing at least some input validation that's keeping the attacker from being able to post the malicious code directly. So what the user is going to do, instead of posting that malicious code directly, they're going to find a vulnerability on that website. And then what they're going to do is they're going to craft a clever link. So let's say that website has a vulnerable search field. That user can actually write malicious JavaScript that will exploit that search field. But instead of being able to store it on the website, what they're going to do is craft that clever link and hide it inside of a phishing email. And so maybe they make this email look very, very official. So let's say you get an email from Airbnb and it says, "Oh my gosh, your credit card has expired. Please click this link to update your payment information." And you click on that web page, or excuse me, you click on the link that's contained in that email, which takes you to the vulnerable web page. The malicious script that you downloaded from that web page is then launched against that vulnerable search input field. And then the attacker relies on that fact that the vulnerable app can return certain search results to you that include the user input that you gave it, which were actually the malicious JavaScript code that you were tricked into clicking on. I know there are many, many parts to this, so take a look at the image down here below. The first thing that it says, again, the perpetrator, the attacker, the first thing they're going to do is embed a malicious script, okay, that will allow them to view your session, pending that you have a session open with, say, your banking account, for example. Second thing they do after they craft this very cleverly written malicious code, they put it in a link to that vulnerable website and they send you that link. Okay, without thinking twice about it, you say, "Oh gosh, my payment information has expired. I'm going to click the link," and you're going to visit that page. Again, as you pull that web page up, remember that that link was very specially and carefully crafted to contain malicious code. So what happens is the website is served to you, your browser feeds it the input from that malicious script, and then the attack is actually reflected off of that website, and the website returns basically the attack to you. So that's the fourth step there. The script actually gets executed by the web application itself, and the results of the web page with the malicious input that you were tricked into clicking on are returned to your browser. And then, as you can see here in the fifth and final step, the browser takes the cookies or whatever piece of information, whatever piece of private data that they're interested in, and by reflecting the attack off the website to you, you download malicious code that then goes ahead and sends your private data to the victim. So it's nearly the same thing as a stored cross-site scripting attack, except, instead of the malicious party hoping that you visit a web page with their stuff embedded in it, they're tricking you into executing their client-side code by giving you a malicious link and then bouncing you off of a website. So that's why it's called reflected. So the difference is somewhat subtle, but please, just for the purposes of this class, understand that the stored cross-site scripting attack requires the code to be actually stored on a web server, whereas the reflected cross-site scripting attack, it still requires a vulnerable web server, but the attacker doesn't have to embed the code into the website. They can actually trick you into injecting it to yourself by reflecting that attack off of a known vulnerable web server. The good news here is that nowadays most web servers and the JavaScript frameworks actually have built-in prevention of some of the various cross-site scripting attacks. So if you haven't worked with a JavaScript framework before, things like jQuery, Ember, Meteor, AngularJS, React, a lot of those front-end frameworks, these things are very common. So they do a lot of heavy input sanitization to make sure that people can't get away with these very sort of primitive stored cross-site scripting attacks. So they are very, very, very diligent about validating the inputs before they're willing to post anything to the internal structure of the framework. So the number one and most effective measure against these types of cross-site scripting attacks is to make sure that you take a look at the input before you're willing to execute it or before you're willing to store it on your server, and make sure that you're escaping the input correctly, make sure that it doesn't contain executable code or things of that nature. But the nice thing is that a lot of these frameworks now do that for you ahead of time. So the other thing that we won't really talk about too deeply in this course, but you might talk about in the context of maybe software security or something, is you can use something called a web application firewall to stop some of these things. And what they do, you can think of it as a you can think of it as like an anomaly detection firewall, but instead of at the network layer, it operates at the application layer for web applications. So they kind of know what to look for when it comes to the structure and the anatomy of these types of attacks. And so they're actually become very adept at preventing many of the cross-site scripting vulnerabilities from being exploited. And of course, as you saw, as is the case with the reflected cross-site scripting attacks, you have to be really careful, and as a user, you need to be educated and be cautious and suspicious of some of these emails when you get them, even though they might look completely valid. You don't want to click on untrusted emails because, as you know, not only can a link lead you to a malicious download that's some sort of malware or virus or worm, but now the other thing you have to worry about are these reflected cross-site scripting attacks where, without even knowing it, it may look completely innocuous to you, but clicking it may allow your credentials or your session information or passwords or bank account balance or things like that to be sent to a user. And the problem is it's all happening behind the scenes in your browser, so you're actually not even going to know it, even if you are exploited. So though they're very, very dangerous, just a little bit of care on behalf of the user and being cautious when opening untrusted emails can go a long way in preventing these types of attacks as well.